Now, let me introduce the expert speaker, Mr. M. Venkatesh, trainer, Cholamandalam MS Risk Service, who has 8 years experience in the field of construction, teaching, and in process industries. He is a certified structural and OHS consultant. Also, he has worked in L&T Construction and MEPCO Engineering College. He is currently working as a trainer in Cholamandalam MS Risk Services. Then I call upon Daniel Jesudasan to address the gathering.
Good afternoon to one and all. It's indeed a great pleasure to admit this gathering. Thank you for giving me such an opportunity. On behalf of Green Club and the Department of Civil Engineering of Amrita College of Engineering and Technology, I proudly welcome you all to the second session of one-day workshop on recent advancement in civil engineering. First, I'd like to welcome our campus director and our beloved principal, Mr. Dr. R.K. Suresh. He is a man with great vision and mission. I welcome you, sir. Next, I'd like to welcome our Honorable Head of the Department of Civil Engineering, Mr. C. Ramesh Babu. I welcome you, sir. Next, I'd like to welcome our resource person, Mr. A. Venkatesh, trainer, Cholamandalam MS Risk Services. On behalf of Department of Civil Engineering of Amrita College of Engineering and Technology, we welcome you, sir. Thank you for accepting our invitation and joining us instead of your busy schedule. Thank you, sir. Now I like to welcome our organization committee members, Mr. D. Akhil Verma, Assistant Professor of Civil Department. I welcome you, sir. Mr. M.S. Kishore, Assistant Professor of Civil Department. I welcome you, sir. Last but not the least, I welcome all the participants for accepting our invitation and attending the second section of the workshop. Once again, I welcome you all. Thank you.
Thank you, Daniel. Now I call upon Mr. C. Ramesh Babu, HOD, Civil Department, Amrita College of Engineering and Technology, to address the meeting.
Yeah, thanks, students, for this introduction and welcome. Actually, Mr. Venkatesh is an expert in finite element analysis software. He did both his BE and ME from prestigious Nagercoil Engineering College. So while studying in college, he was disciplined as well as brilliant. He was getting good scores in all the semesters, and he was interested in ANSYS software as well as Abaqus software and MATLAB. And these softwares are mostly used by mechanical engineers. Even then, he finds the application in civil engineering, and he spends time on working in these softwares. When he was working in Nagercoil Engineering College, he developed so many manuals for working on the finite element analysis software. So that is a different thing, because in our civil engineering field, previously in olden days, people were not having any kind of drafter or drawing equipment or drawing software. In those cases, imagine people were drawing on freehand using drawing tools for putting plans as well as laying roads, building compartments, apartments, laying railways, building airport. So all these type of things were not done by the use of computer. But with the advent of computers, now you can easily draw any structure or any plan or any civil engineering drawing using AutoCAD, and Revit architecture is there. So in future, I would like to invite Venkatesh for giving you training in Revit architecture and ANSYS in future. The ANSYS is nothing but a finite element analysis software where you can simulate events that you are doing in your lab. For example, in our lab, the UTM machine is not working. So you are not able to do the compressive strength test, modulus of elasticity test, and most of the tensile test cannot be done using UTM because it's not working. So you can simulate the same experimental conditions in ANSYS using finite element analysis software, and then you can get the results which will be accurate when you compare with the UTM results, because UTM results manual error may be there. But in case of finite element analysis, there are no such errors, and the software evaluates perfectly and accurately the results of tensile test, compression test, as well as Young's modulus of elasticity test. Also, when Venkatesh was in MEPCO, we used to work together in many projects, including fiber reinforced polymer composites. So that is one part of my PhD work, and he assisted me in working in fiber reinforced polymer concrete structures. We tested using the UTM as well as uh, channels, and we found out the results, and then we wrote many journals and published them. So he is also interested in writing manuscripts for journals in Scopus Index journals, as well as being an expert in all the finite element analysis software. Today he has come up with the new software, that is Abaqus. So most of the time people like you will not be aware of the software Abaqus, but now he will throw you some light and enlighten you with the basic knowledge of Abaqus, that is finite element analysis software, and simulation of the bullet that is acting on steel structures, and how the steel structures are resisting and getting damaged by the bullet from the gun. So this is a different topic in civil engineering, because as civil engineers we are not only confined to drawing plans and executing works, but we also study finite element analysis software and find its application. So I welcome Venkatesh. I will not take much time. I welcome Venkatesh to explain about the fundamentals of Abaqus and how he used the software for simulating the bullet acting on steel structures. And I am also eager to watch Abaqus software, because I am well versed in ANSYS, but I am not able to cope up with Abaqus, because learning any one of the finite element software is enough as far as myself is considered. But Venkatesh is a man who is talented in all finite element analysis software. So thanks, Venkatesh. Thanks for accepting the offer. Immediately I was talking to you. And in this COVID pandemic, let us welcome him online. But after pandemic, when we are returned to college, for sure we will have full day session with Venkatesh, that to offline mode. That is in our laboratory. But I welcome to continue. Welcome Venkatesh, and now over to Venkatesh. Computer can invite Venkatesh and he can start the session. Thank you.
Thank you so much, sir. Hello, am I audible?
Yes, sir, you're audible.
Yes.
Proceed, sir.
Thank you so much, sir, for my heartfelt thanks for my guide. Mr. C. Ramesh Babu is going to soon become a doctor after completing his PhD, because I am very eagerly waiting for my guide to get his PhD done. And without him, my PG would not have been a success, because of his continuous effort, because of his continuous instruction and guidance. Through all these things, I learned some things in my PG, and continued to work in MEPCO also. And thank you, sir. But still, I need to run a very long way to achieve your status. But I will try to get into that, sir. Definitely.
Yeah, I wish you all the best.
Thank you, sir. Thank you so much. Okay, so let me share the screen so that let us go into the topic. So I will not also waste not to waste your time. So yeah, is my screen visible to you?
Yes, sir. Now it's visible.
Yes. Okay. So today we are going to talk and view about impact analysis, and that too, the impact of a bullet or a projectile like a thing on any of our structure, and we will look into how deeply the projectile or bullet like a thing will hit the structure, and what happens to that structure when it got hit. So how the material will behave. So all these things we will see today. So the image what you are seeing is the X-ray image of a bullet hitting a steel plate. So why we need to consider this impact analysis? So majorly there are three main points to consider. The first one is ballistic resistance to structures, and next one is we need to plan our structures for bulletproofing, and third will be advancements in the material science. And why we need to do, again, these 3 points will answer you one more thing: anti-terrorism. Okay, because we you know how the world is going through terrorism and all, because of the, you might have heard in news about the recent Gaza attack. So whenever a bullet is fired, how the structure may get damaged. If the structure is damaged, all the people residing there will undergo they may lose their life because of that. So in order to not only just doing the design, as Ramesh Babu sir said, just not only doing the design part and drawing it and drafting it, it's not a job of a civil engineer. There are much more jobs to it, like this one also. So what is FEM? So for the first and foremost thing we need to look about this analysis will be the FEM. So FEM is considering finite elements. So we are just going to consider a large body. So we are not going to consider the entire body, how it is behaving. So no, because it will be much more tedious, much more impossible to calculate manually. So even though by using computers also, it's some of the parts or some of the calculations may take much more time. So in order to reduce our calculation time and also get an accurate result, so what we are going to do is we are dividing a complete portion or a part into sub portions called as finite elements. So some of the elements, and each elements will have nodes. Nodes are just a dot, okay, where 2 or 3 elements or 4 elements can get connected at a particular node. So how the thing will go is, so by doing your basic calculations, these nodes will give you the value of a particular stress or a particular displacement at that particular point. Okay, so at that particular node. So based on the node value, we will get our result. So that is the basic of the finite element method. And if we do it in terms of using a software, or if we terms of using a manual calculation, then that we term it as a finite element analysis. Okay, so I'll also show you the list of some finite element softwares are there. So the left column that you are seeing is the free student version softwares. So ANSYS also, yes, it is free. Up to 32,000 nodes you can use it. And RFEM, Quickfield, Visual FEA, SimScale, these are free student versions. If you use it through a valid student email ID and password, then you can get your license for it. And some of the other free softwares are also there. So some of them will be free for 1 or 2 months, like a trial period, and then you need to pay. And then some other paid versions are also there, where will not be any restrictions on the number of nodes that you need to calculate. So like that kind of thing. Okay, so here in our impact analysis, so what kind of in which way we will calculate. Okay, so that is also a thing, because in mathematics, if you go, there are n number of ways to achieve a solution. Okay, so here also we need to match what exactly the physics that is going to occur in real nature and with the software. So that is how we can justify, okay, we have completely recreated the model, and whatever the result we are getting in online mode is nearly equivalent to that of a real physical nature. I may not be able to say that the result will always be 100% accurate as that of the physical nature. Sometimes it may not be, because the support conditions or the environment or the working conditions may vary when comparing with the physical nature to the online mode or the software analysis. So in which way? So the way always plays a major role, and here we will solve our problem today by using explicit dynamics. So what is meant by that? So explicit dynamics is So dynamics, you know it. The for example, change in time. So a thing will not be in a constant state with respect to time. It always changes. The change can be of anything. Either it can be a load, either it can be velocity, it can be a displacement, anything that can be coming under the dynamics. Okay. And what is meant by explicit? So explicit means the for example, if you are going to analyze a extremely short timed event, extremely short timed and also extremely time variant job, then we need to calculate as using explicit dynamics. Why? Because there are some kinds of calculations that we need to focus ourselves uh, before just putting ourselves into finding the solution, like support conditions and their boundary conditions, or their contact, how they are contacting, what is the plasticity nature, what is their elastic behavior, or what is the range of the ductile behavior range as per the graph of stress versus strain for that particular material being used. So based on these characteristics, things will vary, and to achieve this exact solution for our physical condition, we need to go into the particular type of solving it. So for example, in a blast and impact analysis, so majorly explicit dynamics will be used. And here in Abaqus, while we solve it, I will personally use Johnson-Cook plasticity. So why it is Professor Johnson and Cook, so they both are scientists, and they formulated how to calculate the plasticity nature, because you know what is plasticity, right? So the ability of the material to regain its original shape will be completely missed out in the plastic state. Okay, so definitely whenever a metal plate is being hit by a projectile, the projectile will just pass on through the metal sheet, leaving the some kind of a hole with the element, the metal sheet. So definitely the metal sheet had undergone a plastic deformation. So how to calculate that plastic deformation? So by means of Johnson and Cook, because they devised a better solution using the paper that I have mentioned here. Okay, so they devised some formula, and based on this, so some of the constant values will be asked when we do the calculation in Abaqus, so which we will see inside. So this is what we are going to do today. So a metal projectile, so like a small cylinder-like thing. Okay, so this I'm going to consider it as a bullet, and this will hit a metal sheet. So let's see what will be the impact analysis. Okay, so I'll stop sharing this, and I will open my Abaqus, and I will come back to you. So in case of any doubts, if you have, please don't hesitate to ask. Okay, so just put your just raise your hand using Microsoft Teams, or put your comments on the comment box or the chat box. I'm very much eager to answer your doubts. Okay, is my Abaqus screen is visible to you? Can somebody confirm me?
Yes, sir.
Yes, sir, it's visible, sir.
Okay, thank you. Okay, so this, when you open up Abaqus, so this is the general page lookout for working on it. Okay, so here you will have the opening session, and if you have any worked database, then you can open it up here, or you can work it with the script also, like command prompts and all, like the same options that you can see in ANSYS. And some links will be there to look into the tutorials will also be there. And based on that, whatever the recent files which you have worked on, that will also be available here. Okay, so I'll just close it because I'll create a new here. So I will not go each and every part. I will go into the options where we will work out our explicit dynamics only, because there are bigger options will be there, and I cannot just explain all the options in 1 hour that I have achieved here. Okay, so let's create a new one, and we'll just save it. So For saving it, I'll just use my desktop. I'll just save it somewhere over here. And in that impact analysis, so just say it. So when you say it, you can see that the saving format will be .cae. Okay, so this is most important. In which file you can open the Abaqus. So the .cae file. Okay, so just save it. Okay, so when you just saved it, at the left side you can see the model database. So this is the model database. Whatever models you create, whatever parts you have, whatever properties of the materials you have, and sections, all these things we need to finally finally give the input, and then only we can analyze our part over here. Okay, so we'll just go. So you can either use the model database option in the left side, or you can go under this option, module. So here you can go into every step to finish up, to do the job, and then finally visualize how your work or visualization will be. Okay, so for the first thing, when you first click the part and then click this portion called as create part. Okay, either you can click this one, or you can, this is the part manager where you can go and see what are the parts that you have created here. So here also you can come and do the create itself. So when you create, so first thing I will create my projectile. Projectile is, it's an extrusion, so solid shaped member. It's not a shell or a wire type. While if you are enwrapping, like as we have said with respect to Ramesh Babu sir, when we do the ME project, we did on concrete confined GFRP tubes columns. So for that I use the option shell over there, because the concrete was covered with a GFRP tube. So here it is not kind of a thing, so I will select solid. Okay, so here let me select it as 0.1. Just create. Okay, so you can close this one. So here now this is the area where we need to draw our part, how our part will be. So I'm going to draw a circular shaped projectile. Okay, so and I need to give the dimensions. So once I give the dimensions, it will be 5 mm diameter. So once you give it, so the 5 mm is confirmed, and after that we need to extrude it. So I'm going to extrude for 0.1 meter, 100 mm. I'll give that, and once you give, so this entire projectile is now created. So this part is available. So you can see here on the part model 1, and here the part projectile is available. So the same thing is available here on the left side. On the parts, whatever we created for the projectile will be there, and these options sometimes we need to fill it up before we do the analysis. Okay, so just creating the projectile is not enough. We need to create the plate. So here the plate will be given, and plate is also here in this same format, and yeah, so plate will be rectangular plate. Okay, and let's give the dimensions. So it is I'm going to use 100 cross 100 mm plate. So don't worry if it goes out of the box, because as we give the dimensions, Abaqus will clear it by itself. Okay, so 100 cross 100 cross 100 cross 100 mm is complete. Now we need to give the thickness. So I'm going to give the thickness as, yes, 10 mm. So once you give that, our plate is also complete. Okay, so we have two projectile, and the next one is plate. Okay, so when you see inside the part manager, you can see the plate and projectile. Okay, next thing is we will go into property. Okay, so why so? Because the impact mainly depends, and also is depending on what kind of material it hits and also what material is coming and hitting it. Okay, so for simplification, I'm going to use the same material for both of the materials over here, for both the plate and also for the projectile. Okay, so let us go and thing one. Yeah, we'll input all the material properties. So I'm going to use material aluminium generally, because all the bullets will generally be in aluminium. So first thing, I'll give the density. So when you go and give the density, it will be 2700 kg per m cube, and after that go to elasticity. So I need to give the Young's modulus. Okay, 70 E9 and 0.33. Okay, so this definitely when you are doing physical calculation, you need to obtain these results from physical calculation. Then you need to manually enter it over here. Okay, now I know the value, so that's why I'm directly going in. So and then during the consideration of a plastic stage, I need to go for Johnson Cook. Okay, so here there are certain values called as A, B, N, and melting temperature, transition temperature. So these are the constant values where this can be calculated using the paper as mentioned in the. So for consideration, I'll just use freely published result. Okay, in this paper itself for easy understanding. The B value will be 113.8 E6 and N will be 0.42, and after that I need to go into mechanical and damage for Johnson Cook damage. So here the D1 is minus 0.77. This one D2 will be 1.45 and D3 is minus 0.47, and the reference strain rate is 1, and for damage evolution, so all these things are going to use it like that, and this will be 0.1. Okay, so it's to simply say all these D1, D2, D3 and A, B, C values on the Johnson Cook damage and also the Johnson Cook plasticity values can be calculated using the formula mentioned in that particular paper. Okay, so from there only these values have been calculated for aluminium. So once the material property is given, so here you can see the material 1. Okay, so we need to assign these values to the particular member, because still now Abaqus, what it's doing is it knows that okay, there is some material is there, but we need to tell Abaqus that okay, take the material value for this particular part that we are going to use it for our analysis. But before that, so what we are going to do is, okay, this particular end, okay, we are going to model like the projectile is coming and hitting this particular end of the metal sheet, and that is where the effect is, how the thing will work on. So that is what we are going to do. So for that, there are some things that we need to do beforehand. So the first thing is we need to create a partition, because when we do the meshing here, so meshing means the process of creating finite elements. Okay, the different number of nodes or the number of elements that we are going to create for a particular part. So that process is called as meshing. So if we do the meshing for a whole part, so what happens is the number of nodes will become more and the process may take more time to solve. So what we can do is we can localize where we are going to apply our load, and depending on that, up to which area we can give a concentrated node value. Okay, so that we can provide. So it's easy. So let's look into it. So this is the phase I'm going to draw, and so let me select this. So I'm going to partition my geometry over here, and after that I'm going to this option because I need the same two lines on the other side also. So that is why. So I'll select, you can select number of multiple elements using shift key. So extrude along direction. So I need it on the other side. So if you give it and create partition, so now that you can see the same line on the other side also, right? So we will limit ourselves where we are going to provide the meshing portions here. And similarly for the next part, that is projectile also. So here also we are going to do the same thing. Okay, so the first thing will be this parameter. So what we are going to do is we are going to consider only quarter portion of this bullet for analysis, and then the quarter result called as a symmetry, it will give you the entire other result for the other half portion. So let's create that half portion here. So why we are considering this kind of only the quarter portion that I have not crossed or that I have not enclosed with the line, only we're going to use it for the calculation, because it saves us a lot of time, and also it reduces the number of nodes for the projectile material that we are going to use. Okay, so just click at it, and if we cut it, yeah, so now the entire bullet is out. Okay, only the quarter portion remaining here. And now, so what we need to do is, so we need to sketch till where we need to give our control over the machine. So for that, again, we will use this option, and so here you can go go backwards using Control Z. So that is a prime advantage with respect to ANSYS APDL, because there are two kinds of software modules that we can use in ANSYS. One is Workbench, and the other is APDL, where APDL doesn't have any backspace. You cannot go one step backward if you do some mistakes in it. But Workbench can go some extent, and Abaqus can go to any extent. You can go backwise any steps. Okay, so we need to give the clearance on how much the length is. So point to point I need to measure. So here it is 0.03. Okay, and after that I don't need this. Only this vertical line I need. Okay, so that is where I need to run it. So partition I need, and that's it. So next will be, I need this particular line over the entire quarter portion of this projectile. So for that, I'll click the option. This option is called as partition cell. So where I'll just select this line, and after that sweep along the edge. Okay, so which edge I need to sweep? Along the quarter circumferential portion. And if you give that, now the partition is complete, and it is over the entire other side portion also. You can see it, right? Okay. So why we are using this? Because when we do the mesh, you can easily see. Okay. So first thing is, our part portion is now complete. Property we have given, and now we need to assign the section for this particular part. Okay, so for this one, so I'll use section 1, and let's select this particular member and give it, and again go for section 2 and select it and give it, and similarly for select the plate, go to create section, select it and give OK, and next will be this one, select the member, and that's it. Okay, so now that we have given all the member property to this particular parts. Okay, so assign section. Let me delete all these things because they are not required, only one is enough. I'll restep this once again. Okay, so section 1 is enough, so solid, and that's it. And now go to this particular section and select it. Based on that, section 1, that's it. Okay, now the property is assigned to this particular material as it turns into green. So now select the set 2 and give yes, and similarly for the projectile, select it, and here also go and select this particular one, select it, and here also go and select this thing. Yes, so now when you go into assignment manager, we have assigned both the projectile as well as the metal plate here. Okay, so now the property step is finished. Then we need to go for assembly. So assembly means first what we are going to do is we can create any number of material, we can create any number of part, but in order to bring down to analysis stage, we need to assemble it at the correct locations. We need to fix all these things. So for that purpose only the assembly portion is used. So click here, create instance, and now select this and apply, and after that select this and apply. So now that both these parts are now assembled over here in the assembly portion. So now what I'm going to do is I'm going to shift this projectile here to this particular node. Okay, so how we can do that is here translate instance. So the moment it is clicked, so it asks here select the instance to translate. So select this one and click done. So how I'm going to translate it? So by using node. So this is a starting node. So I'm just click it, and after that the ending node is here. So once I click that, the projectile will automatically come over here. And if it is okay, if you are satisfied with your assembly, then click here OK. Otherwise, if you click not OK, then the bullet or the projectile or the part that you use for analysis will go into the same state where previously before use of your translate command. Okay, so here only we need our projectile. So this is our correct assembly. Next thing will be step. Okay, so what is step? Step here is we are telling our ANSYS at which step we are going to apply the load over here. Okay, so let's go into it. So initial, and here I'll select dynamic explicit. Dynamic implicit is also there, and here description is impact and time. Okay, so what we see when during the presentation, it's a very short amount of time. Okay, so the time period is not 1 second. I'm going to use 5 e power minus 6. Okay, so that means how much? 5 microsecond. Okay, I'm going to consider 5 microsecond for my time step. That is, whenever the load is started, at 5 microsecond, what will be the result of this impact? So that is what we are going to see. Okay, so just click OK, and after that, let's go into interaction mode. So interaction is nothing but we need to give contact. Okay, general contact, because our projectile material is going to come and contact this metal sheet. So definitely there will be some kind of contact. So how is that contact? That we need to give the reference over here. So general contact, it's explicit because we have selected explicit dynamics here as the process of calculation. So that's why it's incoming. It is coming in the bracket as explicit. So give the OK and create. Okay, so before that we need to give one more material. That's the interaction property. So double click it. So first thing we need to give our contact. So on the contact, so normal behavior, Okay, only we are going to give. And now when you go into the interaction, so general contact you can provide, and here the interaction property will come over here. Okay, so now the interaction portions is complete. Okay, next will be load. So in case of a physical nature where you are completely giving a load and then you are calculating how the material is responding, then you can give the values over here. So here you have point load, create loads, and support conditions, boundary conditions, all you can provide. But here we don't have any kind of load, only the velocity of this particular projectile is going to be the input here, and all the others will be boundary conditions. So we need to define our boundary conditions. So always go for the initial step when you give the boundary condition, otherwise the result will not come. Okay, the end result will not come, because the how to say, when we do the analysis, before applying the load only the material needs to be there. Okay, so that's how the thing works. So step will be initial and give for displacement and rotation, and select the top area and arrest everything, because that will act as a fixed support. Okay, now click on the second boundary condition, and yeah, the same displacement and rotation will be there. And here I will use the two faces of the plate, side plates. Okay. And here what will be restricted is yes, U2, UR, and this one. Okay. So these will be restricted over here, and here also for the next one, these two faces selected, U2 and U3. And similarly we need to give the support conditions for the other ends also. As one side is majorly fixed for the plate, so this area there is no required to be given, but the impact area sides definitely needs to be provided, so that's why I'm giving it. So here similarly here select these things. 1, 2, 3. Okay, so now it is complete, and boundary conditions are over. Then comes the mesh portion. Okay, so before going the mesh portion, I'll select the predefined field. Okay, so why? Because we need to give the input that this projectile is coming at what velocity and hitting this metal sheet. Okay, so for that particular purpose, click the predefined field. So here initial only, and mechanical, go to velocity and put continue. Now select regions for the field. So this entire projectile we need to select, and done. And in the V3 give it as minus 1000 kilometer per second, sorry, kilometer per hour. Okay, so this will be the velocity at which it coming. When you give it, so you can see a basic arrow direction that can show it is coming and hitting the material. Okay, so now let's go into mesh. Okay, so when you go for meshing, always go for the part. Okay, that will, which will give you much more control over how much of the mesh that you're going to provide. Okay, so projectile is here. So first I need to seed it. This edge. So this edge. So either you can give the approximate size number of a particular element, or you can give the number of individual members that you may need. Okay, so here I may go for the approximate element size here. So once you give that, you can see the nodes, okay, at various places, at which places the nodes will occur. Okay, and Abaqus will tell you if you are satisfied with the spacing of these nodes, just click OK. Otherwise, you can again revise it over here. Put it as 0.1. Okay, so now it has increased. When you reduce the size, the number of nodes will go increase. For example, I'm going to increase the size over here. So you can see only 2 nodes are here. And on the contrast, if I add 2 more zeros here, you can see the number of nodes that have increased. Okay, so this kind of spacing we need on this particular portion that is coming and impacting the plate. Here it is not required for that much gaps. Okay, so for that we'll select as 0.1. Okay, so this much of gap, or I can even select it as even a 6 or 7 or something. Okay, so yes, so this will be there, and mesh region. So this region, as we have given it, so this is mesh now. Okay, and similarly go and seed edges. So now select this one and give it as 0.001 and then click apply and okay. So that gaps is okay for us. And then again region. So we have given the input for our meshing. So now the coarse mesh and fine mesh are there. Okay, so that's how it is applied. And next will be the plate. So for doing the plate also we'll do the same thing as we done for the projectile. So first go to seed and then edges. So select this one and give done. So this is 0.1. So let's see how things are there. Yes, it is okay. And then give region. Yes. Okay, the item is meshed, but here we need to go into deeper one. So again mesh, go inside. So now here we need an 0.1. So again mesh and go in region, select it. Yes. Okay, so now the above portion, as there is a junction between both these meshes, so Abaqus automatically updates the gaps where the junction is coming in, and all the other portions will be left as it is. Okay, so save your work. So now that your mesh is complete, so now if you can see the assembly, so this is how your thing will be. Okay, so the part is like this, right? Okay, and let's go into job. Okay. So optimization is done whenever you need to work on material reduction of a particular way in which you can save your material for a particular design. So that's where the optimization can come in. Okay, so I'll go to the jobs. So for the jobs, this will be the thing. We already told Abaqus in which time step we are going to do it. We have selected already the explicit dynamics over here. Okay, so this will be thing. Just give the OK, and after that, open it up, and right click and submit. Okay, when you do the submit job, and again right click and see the result. Okay. Sorry, still the result had not been developed because it is running. The result is running. Yeah. So job already exists. Now that you can see, it is submitted for analysis at the bottom page. And right click and click the monitor. So when you click the monitor button, so how your time step is going on, whatever the results or whatever the logs, errors and warnings are coming up. So all these things will be mentioned over here. So give some time. So definitely it is running. So now that we can see some values, and you can see job 1 is completed, and here also just dismiss. Once it is completed, right click and then go for results. So when you look at the result, So the meshed portion will be visible to you. Okay, so this is where the bullet is going to impact, and click this option, plot contours on deformed shape. When you click that, so this is how it is. So what is the time frame that we are given? We have given the time frame of 5 microsecond. So that means the projectile coming at around 1000 kilometer per hour speed is coming and impacting this particular metal sheet, and at about 5 microsecond it has gone inside like this. Okay, so this is the first step, and this is the step-by-step procedure, and this is how the metal sheet is going in. Is the simulation visible to everybody? Can anyone confirm?
Yes, sir.
Yeah, good to hear. Thank you. Similarly, here we can see that our bullet is just impacting and it is just present on the surface of the steel. Okay, so what can we do? We need to increase our time now, because 5 microsecond the projectile is just entering the metal sheet only up to this depth. Now if we increase the time as a small portion, then we can see how much of the bullet had been, our bullet or projectile has gone deep inside the metal sheet. So for that, what we can do is go again to model and go to the steps. Okay, if you can go here or you can go here, anywhere you can go. Okay, so here you can go to the step manager. So here you can go to step 1. So we are given the time as 5e power minus 6. Okay, so what I'm going to do is double click it, and what I'm going to do, I'm going to give it as 5e power minus 4. That means 0.5 millisecond. Okay, so this is what I'm going to consider for the process now. And once you give that, again we need to give the submit the job again, because we are recalculating all the things. So, and once it is running, you can see the monitor. So based on number of nodes that you provide for your problem, the solving time will take that much. If your number of nodes are more, then more time will be taken for solving. So that is why while doing the meshing, I have selected the meshing in such a way that where exactly we need a result, that is where the fine mesh had been given. In all the other areas, we can provide coarse mesh. Okay, so in this way we can save a lot of time. On also we can save a lot of load on Abaqus. Also the load on your laptop or PC that you are working. Okay, so just the values are coming in. Please be patient. So once it is completely finished, then what happens is the kill button. So kill means you can drop the solving process in between. Okay, so the kill button will become disabled. So that means the process has completed. Okay, so here it is disabled. Now the job 1 is completed. Now let's go here again, right click it and give the results. So again we need to look into the part where we need to focus on. Okay, so this is where our focus will be. Now if we do that, can everybody see? Can everybody
Yes,
confirm
sir.
that you are seeing it? Yes. Now what happened is the projectile had completely gone inside and it is coming out of the other way of this particular metal sheet. So if you can see it by step, and this is how the things will be. Okay. So there is one more way of looking into it. So go and see this one, and by looking into the movie mode, so this is how the bullet or the projectile has entered and come out of this particular metal sheet. Okay, so in whatever way we can see it, right? Okay, so there is one more thing. So go into result and field output. So here what we are going to do is, so in a practical scenario, the particles of the metal sheet and also the particles of the projectile will be thrown as the material is coming in such a big velocity, it will be thrown outward. So there is a value called as status variable, and in it is peak value, equivalent plastic strain at integration point. So what I'm going to do is, this will show you how much of the elements will be completely thrown over on our particular analysis. So this is exactly the result. Okay. So here our bullet is nearly destroyed, or the projectile is completely destroyed, and you can see some spaces. The in-between materials have been thrown out because of the bullet impact. Okay. So I'll clearly show it to you. So parts. So what I will do is, I'll disable the projectile, remove, and now I will run the simulation. You can see it, right? Can everybody see? So when the peak value is, whatever the peak value is more than 1.5, all the material are getting removed from our analysis portion. Okay. So this is how the peak value is shown. Okay, so projectile I will add once again. I'll dismiss it. Right? So this is just an example of how your behavior of impact on a particular metal sheet will be. Okay, so based on this, you can plot again, you can use graphs, and you can suggest how the values are occurring. Okay, so based on that, you can do your analysis portion. Okay, so this is one thing. Let me stop my sharing. I will share you one more thing. So if you give a much more fine mesh, then what happens is your result will be much more accurate. So the advantage of mesh is, to fine mesh, you will have accurate result, but it will take a lot of time and it will give a lot of load in your calculation. But if you give a coarse mesh, then what happens is the problem solving time will be less, and your accuracy of the result will also be less. Okay, so that is the only thing. So what I have done is, I have created a much more finer mesh here for these particular two portions, and I'm going to show you how the simulation will be. Okay, so the job is running. Please be patient. I'll show it to you in 2 minutes. Okay, so till the result comes. Doubts? Anybody? Anyone? Do you have any doubts?
Can you hear me?
Yes, sir. Yes. May I know your name?
I'm Rajesh.
Yes, Rajesh.
Yeah. So here both steel bullet and steel target is being taken, isn't it?
Not steel. I've used aluminum as the material.
Aluminum. Okay.
Yes. Like aluminum, you can use steel also for the analysis.
And you have used a quarter portion for modeling in order to save computational time, isn't it?
Yes, computational time, and also to reduce the number of nodes for the coming calculation. That's why.
Okay. And also, I have one more doubt. That's how regarding the total time. How you decided the total time that is required?
I'm sorry, I didn't get you. What you are meaning by total time?
That earlier you used 6 microseconds, then you converted it to milliseconds, total time of simulation.
Okay. So that part. Okay. So that is just a trial and error method.
Okay.
In the process, the entire process of a bullet travel, definitely it is much more less than of a millisecond. So that is a very general thing. Okay. So by using trial and error, where you can get your required result, you can opt for your timing values.
Oh, okay. And also we have to make sure that the bullet is just touching the target and then start the simulation, right? The
Here
position.
in Abaqus, you need to have a contact with a particular material that it is going to give the impact. But in ANSYS, you can have a small gap of at least 1 or 2 mm to get into the solution. See, basically, if the gap is more, then what happens is, for the bullet travel, your ANSYS calculation will go, and more time will consume. Okay, so we don't
Okay.
want our ANSYS or Abaqus or any FEM software to go into the projectile traveling path, because that we know it will come in the air.
Okay.
Okay,
Okay.
so
So
as
since
as
in Abacus we have to make sure that both have the same common nodes at that
yes, you need to maintain the contact. If you maintain the
contact.
contact, then your calculation timing will be less.
Okay. Thank you.
Yeah, sure. Very much welcome, Mr. Rajesh. So still the process is going on. Any doubts? Because my session is not over yet. I'll show you still some more. And while the calculation is going on, I thought of having an interaction with you.
Sir,
Yes, please.
this is Lima.
Nima, yes. Please.
Lima. So you have selected dependent instance in assembly mode, right? So when can we select a dependent or independent instance? Can you explain that?
Okay, so for that, what is meant by a dependent instance? So definitely your question is a very good one. Okay, the thing is, why we are going to select a dependent thing. See here, whatever the analysis portions that we need to consider, everything are connected, and with the boundary conditions only we need to define our problems. So that is how it is shown as a dependent one. Mostly the independent property will not be used in whatever the method, but in some special cases they are being used, like for example any magnetism. For example, by using electromagnetism, we are having the um, what is that, seismic cushions. Okay, so without any contact. So for that particular problems and solving those particular problems, so the independent contact will be used. Is my answer okay?
Yes, sir. Thank you, sir.
Yeah, thank you, Lima.
Thank you.
Any other questions, guys? So let me check whether it is completed or not. No, still it is going on. So as the mesh is more, so it takes a lot of time. We it will get solved automatically, and you can see the result immediately. So the main process is how you are solving your steps. So if you go every step without missing any of the steps for solving, then definitely you will get your answers without getting an error. And the most important thing in our calculation is the boundary condition. How you are fixing your boundary conditions, in which boundary condition you are, whether you are allowing rotation or not at a particular node or a particular phase. So that also governs your accuracy of your project or the work that you're going to do. So still it is running. So as you can see in the job one, still you can see it as it is still running. So once the work is done, it will come as completed, and that is where we need to look for our options. So if you kill the process, that means if you right click the option, and if you right click the option, you can see it as kill. Okay, so if you kill it in between, then the whole process you need to start once again. So now that our process is completed, now let's go into the result. So on this result, go to the part where we need. Yeah. Yes. So is it clear to everybody? Knowledges. So this is how the mesh I have given. So look how fine and how many nodes are there, and that is how the calculations are getting so much. So as you can see, the metal sheet is just curving out. Okay, so this particular portion. Can everybody look into it? This particular portion, it's curving out. So this is exactly the behavior of a steel plate when you hit it with any kind of a projectile at a high speed. Okay, so and when you just look into the video, yeah, you can clearly see how it creates the impact. Okay, so let me stop this ANSYS one, and I'll show you how the nature here. Yeah, so is my screen visible? So this is actually the physical
Yes,
bullet
yes,
that has been used for this particular bullet like particle that has been used, and exactly this is how the hole is. See, you can see the small upward like projection whenever the bullet hit the particular metal sheet. Okay, so this is what exactly we have achieved in our ANSYS, sorry, Abaqus running. Okay, so the result is very identical, I can say, not exact. So when you again look into the Abaqus one, it is very identical. It is very equivalent, not equal. It is equivalent. So this is how we can predict whether our work done is correct or not. Okay. So I hope the bullet analysis through Abaqus is giving you a good light on how the applications of Abaqus is and FEM in civil engineering. I'm just not going to cover now because I'm going to show you one more thing. So let me go again, stop the screen sharing, and I will screen again for this one. Yeah. So this is how you do in ANSYS. Okay, so this is entirely ANSYS one. So is my screen visible? Anybody please confirm?
yes, sir.
Yeah. So here,
Visible.
yes, thank you so much. So what I have done is, so here I have projected, this is the projectile, a small cylinder I have used as a projectile in a 10 mm thick plate. So this is structural steel. Both the things are in structural steel, and you can see the deformation, right? So clearly, this is the same kind of thing that you can see as per the presentation as I have shown in the first slide. Let me show that to you again. Can all you see? This is the impact analysis on structural steel And this is the same result that we have obtained whenever I have used it and created using ANSYS, right? So when you look over here, then yeah, smooth contours if you provide, and then if you use animation part, then you can see how the bullet has come in traveling. So definitely things will go out of hand whenever the time or the velocity of the material is high. Okay, so likewise I have shown you the result of the impact analysis in both Abaqus and ANSYS Workbench. So these two are the world's leading FEM softwares. So I hope this I have given enough coverage on how the impact analysis is being done and how things are going on in FEM and FEA. So any doubts, guys?